All right, so do you want to start us off? Or actually, we should probably wait to see if he's gonna join. Or no, you did.
Yeah, Josh. Yeah, Josh is here.
Yeah. So I was looking at my other thing. All right, so are we good to go?
Yeah, we're good.
All right. Our webinar will be on sustainable energy. Today we'll be talking about wind, bioenergy, solar, geothermal, and hydropower energy. So we'll start off with wind.
So wind energy. Basically, wind energy is how we can capture the natural movement of air to our advantage for our benefit. Examples of this include using wind to sail our boats across water, or to power windmills for water pumps, or to grind grain. Today, however, the most popular use of wind energy is to spin giant generators for electricity. So why? Wind is a naturally occurring phenomenon alongside being very abundant, which leads to low to no emissions during the farm's operations. Besides that, uh, the setup for wind farms is relatively cheap compared to other forms of sustainable energy, leading to faster scaling of wind farms. Notably, there are two types of wind farms. So the first wind farm was set up in 1980 in New Hampshire. Now there are at least 40,000 wind farms in operation currently. The basic principles of these farms are all the same. Wind spins a blade that turns a generator to produce electricity. The two types of farms are onshore and offshore. Onshore are installed on land, and they are cheaper to install, maintain, although they won't capture wind as consistently as offshore farms. Besides that, the farms make a considerable amount of noise that can disrupt life around the farm. And then offshore farms are installed in a body of water, and they produce a considerably more amount of electricity than onshore farms. The drawback is how expensive it is to set up, maintain, and run the power back to land. Maintenance for these farms are considerably more expensive due to the harsh marine life. Downsides, while on paper it seems fantastic, there are some things you have to consider, from the size of land that these farms will take up to how it affects wildlife and people around it. Wind may be abundant, but inconsistency is still a problem with these farms because we can't control wind or the weather. Another big issue with these is that the blades have a lifespan, and once that's up, it's supposed to be recycled. But the problem with that is that recycling these blades is hard and very expensive, leading to a lot of times where they just get dumped in a landfill instead of being recycled. So to wrap it all up, overall, using wind for electricity is one of the simplest forms of sustainable energy. It may struggle now with some issues like the blades, but the winds of our advances will surely fill our sails, driving us to refine the process and harnessing wind energy more effectively.
All right. For bioenergy, bioenergy is a renewable resource that comes from organic materials, aka biomasses. Biomass can be made from crop waste, forest residues, purpose-grown grasses, woody energy crops, microalgae, urban wood waste, and food waste. Biomass can be used to produce transportation fuels, heat, electricity, and some bioproducts. For biofuels, in this case, biomass is converted into liquid fuels, aka biofuels. These fuels are used for transportation purposes. These biofuels are used to make ethanol and biodiesel, which may fuel many vehicles and even airplanes. Using biofuels help lower the amount of carbon emissions coming from vehicles and planes. Biopower. Biopower is converted from biofuels and is turned into heat and electricity, done in similar ways as fossil fuels. The three ways that this is done are burning, bacterial decay, and conversion to a gas or liquid fuel. Using biopower can decrease carbon emissions by limiting the need for burning carbon fuels. And bioproducts. Bioproducts are created similar to products created using petroleum, except they use biofuels. Some bioproducts are plastics and industrial chemicals. To wrap that all up, bioenergy is a great renewable resource that is used in many different ways. It creates a lower carbon footprint as well as helping the economy in the US, making us less reliable on non-renewable sources, such as fossil fuels. Any questions? Post in the comments. Sweet.
So, solar energy. Solar energy is a renewable energy source that harnesses the energy from the sun. It can be converted into electricity, or it can be used directly for heating. The sun actually produces an immense amount of energy, and in just an hour, the Earth receives enough solar energy to power all of humanity for about a year. The first type of solar power is solar electricity. It's used solar panels or photovoltaic PV cells that converts sunlight directly into electricity. These panels are often installed on rooftop solar farms or even in portable applications. As sunlight hits the PV cells, it excites electrons that generate a direct current, and this is then converted into an alternating current for home and grid use. Another type of solar power is concentrated solar power. It's another electric form, but unlike PV panels, it's concentrated using mirrors or lenses to focus a large area of sunlight onto a small point. This concentrated heat is used to produce steam that drives a turbine to generate electricity. The CSP is often used in large-scale power plants in sunny and dry areas. Solar thermal heating is a more passive way to do it. On the right, you can see this is just a water heater that uses just heat from the sun. So solar energy can also be used for heating water, as seen right here, or indoor spaces. The solar thermal systems capture sunlight into heat, a fluid, which is then used to provide heat, hot water, or space heating in residential or commercial buildings. This method can significantly reduce the need for natural gas or electric water heaters. And the benefits of solar energy: there's zero carbon emission during operation. It's renewable and abundant, pretty low maintenance costs, and they create jobs in manufacturing, installation, and maintenance. However, the challenges of solar energy is that because it's produced by the sun, it is very dependent on weather and time of day. It requires a lot of space for installation, and especially at a larger scale. And initial costs for installations can be high, but the prices are decreasing as times go on. And you need energy storage like batteries so you still have power during low light or night. And to wrap that all up, solar energy is a powerful renewable source that can provide clean electricity and heat. With advancements in technology and decreasing costs, solar is becoming more accessible worldwide. Continued investment in solar can lead to a more sustainable and independent energy future.
Alrighty, so now we'll be talking about geothermal energy. So I'll start by kind of defining what geothermal energy is. So essentially, geothermal energy is energy is obtained from underneath the Earth's surface. So heat can be stored in things like rocks, fluids, and steam beneath the surface, and we can use geothermal energy plants to extract that heat and then generate electricity from that heat. It's a very renewable and sustainable energy source that works year-round, and unlike other forms of sustainable energy, it doesn't really rely on weather conditions or certain seasons to power correctly. So there are three main types of geothermal energy plants. The first is steam, then we have flash steam, and then binary cycle. They all work pretty similarly, but there are some main key differences between them, which I'll highlight as I go deeper into them. So starting off, we have steam. So this type of plant takes in steam directly from underground, like steam reservoirs, and the steam is used to spin a turbine and then generate electricity. So as you can see in the diagram here, steam comes up through a little pipe. It then goes into the turbine holding cell, which spins the turbine, generates electricity. Leftover residue goes down an injection well back into the earth, and the spinning turbine generates electricity. This is the oldest and simplest type. It was actually first used in 1904, but isn't very popular today as some advancements have into like the design have allowed other types of plants to flourish more. The second type is flash steam. So this is very similar to steam, except for the difference is it takes high pressure water from underground rather than steam. As this water goes up into the flash tank, the pressure drops and turns into steam. So in terms of geothermal energy usage, some countries that use geothermal energy are Iceland, the Philippines, even some western parts of the US like California and Nevada. Geothermal energy also powers 90% of Icelandic homes, and I think about 25% of their electricity overall. So Iceland is a very huge like proprietor of geothermal energy. And then in terms of power, the energy that comes from geothermal energy is very stable, as it can be harnessed like any time of the year. It's also very effective in powering heating homes, like we see in Iceland. And it's also used in Japan to like heat hot springs naturally in some cases too. So it's a lot of uses. All right, and then some cons of geothermal energy are that the cost, there's a high upfront cost due to like drilling and setting up the plants, and it can make them hard to scale and then grow in general. The location is also a huge factor as the plants need to be in specific locations that allow for steam reservoirs or high pressure water to be accessed easily. So you can't set up them anywhere in the world. There needs to be specific requirements. And also they have an impact on the earth. The plants can cause some minor seismic activity that could lead to potentially things like earthquakes or earth damage. So it's something to take into consideration as well. Yeah, so in conclusion, geothermal energy isn't the most widely used renewable energy source, but it does offer stable, efficient, and low emission power. As more countries start to use geothermal energy technology, I wouldn't be surprised if it became a major source in the future as time goes on.
All right, so I'll be talking a little bit about hydropower. This is a picture here of the Hoover Dam. All right, so let's get into it. So hydropower is a form of energy generation that uses water. The common through line in hydropower is water that is already running will be run through a turbine. That turbine will spin and turn a generator to generate electricity. This can have a lot of different uses, either supplementing the grid. It can act as a major form of energy generation, powering entire cities, or it can just be set up along an existing river or something similar. So according to the Department of Energy, there are three main categories of hydropower generation, those being diversion, impoundment, and pump storage. So the first one is diversion or run-of-river. These run-of-river facilities will leverage an existing river and the slope that it creates in the land going downhill to divert a small channel of water and have water run down that channel, spin a turbine, and then reconnect with the main river. This is pretty non-invasive. It's fairly small and can be implemented along rivers in multiple points to generate larger electricity. Impoundment facilities, also called storage facilities, tend to be much larger systems that connect either directly with a reservoir that's man-made or artificial, natural, whatever it may be. A popular example is, again, the Hoover Dam. Whenever they need to generate electricity for Las Vegas, they will push water through these large vents that will spin massive turbines, turning a generator and generating electricity. The last one is pump storage. So pump storage uses an above ground and a below ground water reservoir. And these two reservoirs will have pumps set up on them. So at times of low energy demand, they will pump water from the below ground to the above ground reservoir. And when they need energy, they will drain it from the above ground through turbines back to the below ground to just endlessly cycle that water. All right, so just to wrap up, hydropower offers the opportunity to power a lot of different resources, both in a very small scale, just setting up along a river, and very large scale with things like dams and hydroelectric power there. And continued investment could see these technologies expand to more remote locations due to how non-invasive they are. All right, and these are some of our sources that we got our information from.